Let's subtract mixed numbers. Now with mixed numbers, we need to make sure we have common denominators, and that's in the fractional part of these. Now when I subtract mixed numbers, or add them for that matter, I like to do so vertically. So I'm going to go ahead and write the minus 3 3/8 underneath, just because I think it's easier to work vertically, and this is why. We're first going to start with the fractional part. So when you're looking at 7/8 minus 3/8, in this case, we're starting with an easy example, and I say that because our denominators are already the same. So when I subtract same denominator, 7 minus 3 is 4. Then I look to the whole numbers, and 8 minus 3 is 5. Now, hopefully, you look at this and say, well, 4/8 should be reduced. 4 goes into 4 one time, 4 goes into 8 two times. So this reduced answer is really 5 1/2. That's the basics. Unfortunately, not all of our denominators are start to be equal. So again, I'm going to start by putting minus 3 1/4 underneath, because I like to. If you're okay horizontally, work horizontally. You have to do what works for you. So I look at my fractional piece, and I notice that 6 and 4 are not the same. So I need to change these, right? I need to find equivalent fractions where we have common denominators. So 6 and 4 both go evenly into the denominator of 12. So think about in the top fraction, 6 times 2 is 12. So 5 times 2 is 10. So the equivalent fraction there is 10/12. In the bottom fraction, 4 times 3 is 12, meaning 1 times 3 is 3, and now I have common denominators. So I can subtract. I know that my denominator is going to stay 12. 10 minus 3 is 7. Don't need to reduce. And then 6 minus 3 is 3. So my final answer, 3 7/12. Now that's not too bad, but what happens if we need to borrow, right? Think back on your subtracting days, and borrowing is a thing. All right, so 7 1/5 minus 3 2/3. First things first, 5 and 3 are not the same. So 5 and 3 both go into 15. So I'm going to change to a common denominator of 15. In my top fraction, 5 times 3 is 15. So 1 times 3 is 3. In the bottom fraction, 3 times 5 is 15, and 2 times 5 is 10. Now, when I subtract, hopefully you notice that 3 minus 10 does not work. So I need to borrow. Now, when I take 1 away from 7, if you think about that, I take 1 from 7, and I'm adding 1 to the fractional piece. Well, I need that to be a common denominator, right? So if we think about what is equal to 1 with a denominator of 15, and that answer is 15/15, because if you have the same thing on the top and bottom of a fraction, you have 1. So 3/15 plus 15/15 is really 18/15, and now I can subtract my 10/15. So there's a lot of work there in the fractional part of this problem. So now 18/15 minus 10/15 gives me 8/15. And in my whole numbers, I have 6 minus 3 is 3. So 3 and 8/15. Let's do one more just for fun. 8 2/3 minus 3 7/8. Okay, so I'm looking at this, and I check out my denominators. Words are hard sometimes. 3 and 8 both go into 24. So in the top fraction, 3 times 8 is 24, so 2 times 8 is 16. There's my equivalent fraction of 16/24. And in the bottom fraction, 8 times 3 is 24, so 7 times 3 is 21. So again, 16 minus 21, nope, I need to borrow. So when I borrow from 8, I'm taking 1 whole. And so the 1 whole would be 24/24, because we want to keep the common denominator. So my top fraction is now 16 plus 24, which is 40/24, minus 21/24. And when I subtract 40 minus 21, I get 19/24. And 7 minus 3 is 4. Final answer, 4 19/24. I hope you enjoyed subtracting mixed numbers.